So the question is, we have to find the middle of a linked list. So we are given with the head of a singly linked list and we have to return middle node of that linked list. So for example, if we see example number 1, we have odd number of element or odd number of node in the linked list. So here the middle element is this 3, middle node is this 3, so we will return this 3. And in example 2, we can see that we have even number of node in the linked list. So in this type of example, we will have 2 middle node. So in case if we have two middle node, then we will return the next node. So in this case, we have 3 and 4 as the middle node, so we will return 4. Sorry, so let me explain. Okay, so this is the linked list. We have head here. What we will do, we will take one fast node here, point it to head, take one slow node here, point it to head. And after that, what we will do, we will move fast 2 ahead and slow 1 ahead simultaneously. But the condition should be that fast is not equal to null and fast next is also not equal to null. So here fast is not equal to null and even fast next is also not equal to null. So what we will do, we will move fast 2 ahead and here slows also 1 ahead because we have to move both of them simultaneously. And then fast goes here, slow goes here. So at this moment, what we will realize that fast next is null now. So after this, what we will observe that the slow is at the element which is the middle of the linked list. So we have got the middle node. So what we will do, we will simply return that, return slow, and then after that it's easy. So this is only the explanation. Let me show you the code. This is the code. There is one phase condition also, that if head becomes null or head next become null, so we will return head only. See, for example, if we have only one, if we have no element, only null, and what we will return? Nothing. We don't have any middle. Suppose we have only one element, not. So in this case also we don't have any middle. We have only one element, so that is all only gonna be middle. So we'll return head. So that is the base condition. And here in this code, instead of fast and slow, I have taken as RAB and TOR. RAB is fast and TOR is slow. So while RAB is not equal to null and RAB next is not equal to null, what we will do, we will move RAB 2 ahead and TOR 1 ahead. And at the moment when RAB becomes null or RAB next become null, we will stop and we will simply return TOR, which is the middle element. So let me show you the try run of example 2 also. So in example 2 we had 1, 2, 3, 4, 5, 6. This is the head. Let me take this as fast, slow. Is fast equal to null? No. Is fast next equal to null? No. So we will move fast 2 ahead, slow 1 ahead. Is fast equal to null? No. Is fast next equal to null? We move no. So we will move fast 2 ahead and slow 1 ahead. Is fast equal to null? No. Is fast next equal to null? Wait. This is pointing to null. Yeah. So is fast equal to null? No. Is fast next equal to null? No. So we'll move fast 2 ahead. At this moment, fast is equal to null, and slow will also move 1 way. So at this moment, what we see that fast is at null, so we will not move fast anymore, and we will simply return slow. And the slow is 4 here. Return slow. So in that example also, we can see that the middle node is 4. So by this, we are done. Let me submit the code to confirm you all that it works. Okay, so the code is accepted and it works. Thank you.